Okay, we're going to have a quick look at determining an inverse function as well as its domain and range. So let's start with question 1a. So let's quickly read the question. For each of the following functions, state the range of the function. So the range of my original function. Determine the inverse. So we get the inverse, and then we get the domain and range of the inverse. And this is sketch graphs. I think we're actually going to sketch the graphs on that journey. So let's have a look at this first one. So f of x, so we go 1a, f of x is 2x plus 3. X is all real numbers. I'm going to start off with that graph. So if we go calculator, we go grapher, and I'll go 2x plus 3. And let's have a look at this plot. So as we can see, if I go, because I can go x all real numbers, I can see that y is just keeping increasing forever and ever in this direction, and y is decreasing forever and ever in this direction. So my range is going to be all real numbers for that original function. So let's actually write this out a little bit neater. So I say domain is x is all real numbers. And I'm going to say the range is that f of x is all real numbers. So y can take all real numbers. Let's find so that's the range of f of x. Let's now find that inverse function. So what I'm going to do is I'm going to set y equals 2x plus 3. And I'm going to solve for x. So I've got 2x equals y minus 3. X equals y minus 3 over 2. And I'm going to swap the notation around. So I'm going to say f to the minus 1 x. So my inverse function is x minus 3 over 2. That's my inverse function. And then we're going to state the domain and range of my inverse. So the domain and range swap. So my domain will be the range, well in this case they're the same. My domain will be the range of my original function, which is just x is real. So this is my domain here. I mean they're the same, so it's not really too informative. So x is a member of real, and then my range is going to be this. So it's just f to the minus 1 x is a member of the real numbers. So I think it's a bit more clear when they're actually different. And then let's sketch this on the same graph. So I've got x minus 3 over 2. So let's go grapher. I want to add an element. X minus 3 divided by 2. Plot. And there should be reflections. Let's go auto axis. There should be reflections over y equals x. So you see how there, if I imagine that line, I don't know if I can draw, no I can't really, but if you imagine the straight line y equals x going straight through the origin, you can see how they are reflections of each other. So that's perfect. So let's try and now answer one which hopefully has a more limited range, so we can see that domain and range swapping. Let's try, these are all x is real, x is real. Here we go. So let's go with these ones. They've got a restricted domain. Let's go with, we'll go with this one. So we're going to solve g of x, x is real, x minus 7. So we're doing, I think, basically the same question. I've got to look at the range of g of x, then the inverse, the domain and range of the inverse, and then I've got to sketch. So let's do that. So firstly I have g of x equals square root x minus 3. And I've got my domain is that x is a member of the real numbers, can't have any imaginary numbers in this function, and x is greater than or equal to 7. So we're going to look at the range of this function. So let's go ahead and plot that. Square root x minus 3. Open it, but expressions, delete, square root x minus 3, and we go plot. And x is bigger than 7. So my domain starts here at x is bigger than 7. So let's go exactly to x is 7. Okay, so my domain starts here where y equals 2. So everything to the left of that point doesn't exist. So y equals 2 when x equals 7. And then as we go, we see that y is just continuing to increase. And that will carry on forever and ever and ever. So let's go back to auto. So my range is g of x is greater than or equal to 2. I'm matching the notation in the question. So in the question it was greater than or equal to, so my range is greater than or equal to. So now what we're going to do is we're going to find the inverse. So I'm going to say y equals square root x minus 3. So then y squared equals x minus 3. X equals y squared minus 3. So then I'm going to swap the notation around and I'm going to say g to the minus 1 of x equals x squared minus 3. Okay. Now, I've got to find the domain and range. So the domain and range. So the domain and range swap. So the domain is going to be x is greater than or equal to 2. And the range is going to be g to the minus 1 of x is a member of the real numbers. And g to the minus 1 of x is greater than or equal to 7. So the domain became the range became the domain. And now we can plot this. So x squared minus 3, we'll plot that on the same graph. So we go expressions, add x squared minus 3, plot. And you should see they're reflections of each other. So you can't really see that they're reflections as you... Oh, hello, did not enjoy that. Let's zoom out a bit, scroll along a bit, whatever. So you can't really see that they're reflections of each other unless you're looking just in that first quadrant. And you can imagine a straight line going through y equals x, and you can see how they're peeling off in two different directions. Nice. So I think we'll do one more. So we'll do G here because that also has a limited domain. Question E. That's what I mean. So let's do this one, and we'll finish with this. So highlight there. So I have g of x equals x squared plus 2. My domain is x is a member of the real numbers. X is greater than 2, so not greater than or equal to this time. So range, let's have a look at the range. So we're going to plot it, x squared plus 2. Expressions, delete. X squared plus 2. Plotterino, and then I've forgotten the domain. X is greater than 2. So if we go calculate, we can put x is exactly 2 here. So when x is 2, y is 6. So that's going to be my lowest point on this graph. And then I think y is just going to keep going. So my range of y values that I can have, the lowest is going to be y is 6, and the highest will be absolutely anything. So the domain is going to be g of x is greater than 6. Okay, so now we can find that inverse. So I have y equals x squared plus 2. X squared equals y minus 2. X equals plus or minus square root y minus 2. And we have to make a decision which one it's going to be. What we can do is we can actually plot both, and we can see which one is the reflection of my original graph over that y equals x. So we're going to have a look. So let's write out the two possibilities. So it could be that g minus x is minus root x minus 2, or it could be that g to the minus 1 of x equals square root x minus 2. We've got to see which one is the reflection of my original function over y equals x. So let's plot both and we'll have a look. So if I go expressions, I can go minus square root, x minus 2, x minus 2, I'll go okay, and then I can go square root x minus 2, and we can plot that. So I've got to look which one is the reflection of my original. So my green line is my reflection of my original function. So that is, which one's the green one? It is square root x minus 2. So delete that. So I have inverse function equals square root x minus 2. Here we go. Get that there. And then we've already plotted it, so we've done half the question already. So here we go. And then I'm going to have its range and its, its domain and its range. So they're going to swap. So it's domain is going to be the range of the other one. So it's going to be x is greater than 6. And its range is going to be the other one of here. So it's going to be g to the minus 1 of x is a member of the real numbers. And g to the minus 1 of x is greater than 2. And there you go. So that's some inverse function. Hope that helps.